here today. So before we begin, any questions about any of the things you've been working on up until this point? Anything you want me to cover in class today that's not on the agenda? All right then. So today I'm just going to remind you a couple things coming up. We're going to review assignment 2. So that's our text calculator. We're going to review if statements and relational operators, else and else if, logical operators, and then we're going to work on an in-class assignment. And this is all stuff you should have already at least gotten introduced to in the Chapter 3 reading. So if you haven't completed the Chapter 3 reading yet, I will give you until, I don't know, tonight at midnight to do it. So if you haven't done it by now, please do that. So anyway, reminders. So assignment 3 is due this Friday at 11:59 p.m. Any questions on that? Anybody have any problems with that so far? Okay. So, and then we're going to have quiz 2 on Thursday. That's going to be over Chapter 2 and basic if statements. So on that, you should expect to see things about, let's see, what was on Chapter 2? Assignment operators, random numbers, and then probably some questions about if statements from Chapter 3 too. So be prepared for that. So anyway, assignment 2, which was our sales tax calculator. So I'm just going to go through and do that really quick. I did grade it. You should see your grades on D2L now. We'll call it tax.c. So we're going to have two variables. We're going to have subtotal. We're going to have tax. And then we're going to have a third one called res to store the calculation or the result of the calculation that we're doing. So we need a printf statement to prompt the user to input the subtotal. So LF, wrong one. So right now all that will do so it'll prompt to input the subtotal. Remember, if we leave the /n off the end of our printf, it won't take the prompt down to the next line, so it looks real nice like that. So let's say our subtotal is 10, and that's all it would do right now. Remember that even if we type in integers, well, essentially, if we're reading into a double or a floating point value, we can accept either integers or decimal numbers. They'll be converted and stored however we specified. So then we're going to input the tax rate. And then finally, we're going to calculate the result. So we're going to take the subtotal plus the subtotal times the tax rate. And then we're going to print the output. And the output is total is %i new line. And return 0 at the end. I want to print a decimal, so I forgot to do that. I need to go back here, change that to %f. And we did also want to print it with 2 decimals of precision, so we need to say %.2f instead of just .f. So 10.07, we get 1070. Let's do it again, say 100, 0.07, we get $107. So that's the tax calculator. There's a couple different ways you could have done the actual calculation, but as long as you got the right result, I should have given you full credit for this. So any questions about that? All right, I will drop that in dist, so if you want to look at this source code later, it will be dist assignment 2.c. So from your perspective, you could say nano dist assignment 2.c, and you could look at that source code if you wanted to later. So I'm just going to review what we talked about on Thursday really quick. So we got relational operators. So put something on the left, put something on the right, put a relational operator in between. The result of that expression, if it's true, or the result of that expression will be 1. If it's true, it'll be 0 if it's false. If you put something, if you put one of these relational operators inside an if statement, then let's say this. Let's say a is in fact greater than 10, then this body of inside the if statement is going to execute. So just remember, it's a variable or a literal logical operator. That's not what I meant. Relational operator. Should have changed that. We'll talk about logical operators later. Relational operator and then variable or a literal on the right. So remember, 1 equates to true and 0 to false. So, and then we had our basic if statement. So just for a little bit of review here, let's say we had int a equals 10. Remember, if a equals 10, and then we need brackets here, and we'll execute statements inside here. So generally speaking, just remember that there is no semicolon after this if statement here. So there's no if, or there's no semicolon at the end of this line. There's only semicolons at the end of lines where we have function calls like this. We only have semicolons on lines that actually have statements on those lines. So this wouldn't be correct. If you do this, what's going to happen is it's going to test this condition right here, and then it's going to execute this regardless. So let's see what the difference looks like. So obviously this is just going to print a is 10. Let's change this to be a is 9. So obviously that condition is going to be false and nothing's going to happen. But if we accidentally put a semicolon at the end of our if line, we run that again, and that condition is magically true. So just keep that in mind. If you accidentally put a semicolon at the end of your if statement, it's going to break things. So the reason that happens is we can actually have just a block of code sitting in our code somewhere. It doesn't necessarily have to have an if statement, or like it doesn't have to be main or something like that. If we just have something contained within 2 brackets, it'll just execute as soon as it's going through. So the reason that an if statement works is we're attaching this if conditional to that group of statements. So again, this is being attached to this block here. And this block, so this entire thing right here, only executes if the condition we specified in our if is true. So yeah, and we got all those other different operators. So we can do greater than or equal to, less than or equal to, and then not equal to. Those are the comparison relational operators that we have right now. So the new thing that we're going to talk about today that you again should have seen in your reading was else if. So we can use an else if to test for another condition in addition to our if statement. So the condition will only be tested if the previous condition was false. So if this condition was false, then we'll go down here and we'll test this condition. And the same thing that applies to normal if statements applies to else if statements. So if this condition is true, then we're going to execute the statements inside here. And if this condition is true, we're going to execute the statements inside here. The thing to remember with else ifs, so there's a difference between saying this. So if you say if and then another if statement, that's different than saying else if. So when we say else if, again, the difference between having 2 separate if statements and having an else if statement is the condition will only be tested if the previous condition was false. So if this condition, again, is true, this condition specified right here, whatever that may be, if that's true, then this condition will never be tested, and these statements will never be executed no matter what happens. So let's go and look at that. So instead of doing this, we're going to read into A, just so we can simulate different input without recompiling our program a bunch of times. So we'll say if A is equal to 10, or we'll switch this around the other way. We'll say in our first condition A is equal to 10, and in our second condition we'll say A is not equal to 10. So go ahead, compile that, run it. So right now we can say if we put in 10, it'll say A is 10. Put in 11, it'll say A is not 10. And with this one, we could accomplish the exact same thing by saying if statements, because when we're testing this, obviously A can never be equal to 10 and not equal to 10 at the same time. So one of these if statements is only going to be true regardless. The difference is we are going to test both of those conditions no matter what. So even though we change that to just be two separate if statements, it still has the same function. But let's say we wanted to do something like this. We'll say greater than or equal to. So we'll say else if A is greater than or equal to 10. So when we're going through and doing this, obviously we're going to still test this condition. But remember, if this condition specified right here is, so in the first case, if it's true, we're going to just execute this one statement. Now, if it's false, we're not going to execute any of this, so none of that's going to be executed if it's false. And we're going to go down here, and we're going to test to see if this condition is true right here. So if that condition is true, then we're going to execute this, or execute this entire block here, I should say. So let's go ahead and run it. So 10 is, or A is 10, 11, A is greater than or equal to 10. So talking about what we were talking about before, we can go back and we can remove this else here and just say if. So recompile it. So now when we put in 10, we're actually going to test both of those conditions. So now just instead of saying A is 10, we're also going to say A is greater than or equal to 10. So we want to use else if statements when we only, when there's multiple conditions that could be true, and we kind of want to enforce the precedence of those conditions. It's also makes programs run faster, because if we're testing these conditions and we don't need to be testing them, so let's say we go back here. So again, remember that when we're doing this, even so when we're doing this, we're only going to have one test if it is 10, but if we're doing this, we're always going to have two tests regardless of if it's 10. So just kind of simplifies code. Theoretically, it would make it run faster if you had millions and millions of lines, but also just makes more sense if you're doing comparisons on the same number and you want one unique thing to be ran. So then, the next thing we're going to talk about is the else statement. So we can add an else condition onto any other if statement or statements. So we could have a single if statement and then have an else statement after it, or we could have an if statement and then any number of else if statements. So that holds true with just the else if statements too. So we can say else if A is greater than 10. So I'll go from here. So we can have any number of else if statements that we want to. So we can chain obviously as many as we want to onto this first if statement. The only thing you got to remember is you do have to have the first original if statement when we're working on this. So and all of these conditions would have to be different. I think if I went and I compiled it right now, well, I guess the compiler doesn't care. Some compilers would care that you're testing the same thing and not doing anything different. So again, you could go and you could say, change all these conditions. And until it found a condition that it was true, it would continue executing conditions down and further and further and further. So that's else ifs a little bit more. But let's go back. And instead of testing whether, so remember how we did it? We did else if a equal or not equals 10 to test to see if it was not equal to 10. When realistically, we don't necessarily have to do that. With else statements, what we can do, I'll just change this to be right. Instead of testing another condition, so it just adds another conditional test, if we want sort of a default block that will always run when no other conditions are true, we can just say else. So we can take that off, and instead of saying that, since it can be either this or either that, we could say else instead to simplify our condition. So if this is true right here, then these statements right here will be executed. Otherwise, regardless of what a is equal to, it will execute these statements right here. So let's do this. We'll run this really quick, just show you that it works. A is not 10, okay? So let's do this. Let's put a few more else if statements in between our two statements, our first if statement and our else statement here. And we'll say, instead of saying A is not 10, we will say A was not matched. So we'll do this. So now when we run it, when you type in 10, we'll get A is 10. 11, we'll get A is 11. But if we type in 100 or something like that, it'll say A was not matched. So again, looking at this, all of these statements are all chained together, and regardless of what you're doing, only one of these bodies will ever be executed. So based on the conditions, only one of these will ever be executed. So again, if we have this being true, this will be executed. If this is true, then this will be executed. Otherwise, as long as no other condition before it has been true, then we will go ahead and execute these statements. So any questions about if statements and the else ifs and the elses? All right. So the next thing on the agenda is logical operators. So one of the things that we can do is we can chain multiple tests together inside of our if statements. So if we have an if statement, we could do this. We could require two conditions to be true by saying and. So we'll change this around a little bit. We'll say A is greater than 10 and A is less than 100. So when we say and, both of these conditions need to be true. So this side right here, this needs to evaluate to true, and this side also needs to evaluate to true. So when we run this, I didn't compile it yet. So if I say 20, 20 is greater than 10, but also less than 100. So let's go back. The second one that we can use is or. So we can say the expression on the left or the expression on the right is true. So in this case, that's going to be any single number that you put in, because whatever number you put in is going to be it's going to be either greater than 10 or less than 100. So 200, it's greater than 10, it's good. So that's read as or, so you can choose either one of these to be true, and this body will be executed. Remember, if we have 2 and ampersands, so that's 2 pipes. That should be right above the enter key. That's how you would write OR, and this is AND. So again, if this condition is true and this condition is true, these are both required. So if I go back and I put in 9, 9 is less than 10, so we're not going to print anything out. And even though it's less than 100, we say AND because both of the conditions that we specify need to be true. So we can chain as many of these conditions together as we want to. So we can say A is greater than 10, A is less than 100, and let's require A to be even. So that's going to be a little bit more difficult. But remember, if we say A mod 2, and then test if that is equal to 0, then run it again. So let's say 20, that's good, but 21 isn't because it's not divisible by 0, or it's not divisible by 2, therefore it's not even. So we can chain as many of these together as we want to. Now we can also chain together things like combine multiple ands and multiple ors if we so choose. So this would, yeah, and we have to do some of this stuff. We have to put parentheses around things if we are using different types. Well, it's not necessarily required, but it does suggest parentheses around that, like it says. So let's say we put in 99. It's good because it was between, or is greater than 10 and less than 100. But we could also put in any even number because we have the OR separating our relational operators instead of an AND separating all of them. So it's going to test, it's going to test these conditions. If any of these are true, then we're going to execute the body. Or if this statement is true, then we're going to execute the body. So it'll choose either one. It's worth noting if one of these is true. So if this is true immediately and it's separated by an OR, then it's not even going to test the second part. It's going to immediately execute the body. That's important later when we're talking about other things. So remember how I talked about if we have a, I guess I should say this, the final logical operator that we have is the not, which is an exclamation point, and that will invert the trueness or falseness of the condition that we have. So let's say we had a condition, I'll space this out here so you can see it, A is greater than 10. So if we were to put a not out in front of that, what that's going to do is negate this and say, essentially it's going to change that greater than, so A is greater than 10. We're going to say the opposite of that, so the opposite of greater than is less than or equal to. So run that. So normally this would be true, but in this case we negated that condition, so that's good. That's good, and so on and so forth. So remember, if we didn't negate the condition, that wouldn't be valid, but 100 would be valid. So use the not to negate your condition. So, yeah, for any expression you can do that. So the final thing I wanted to talk about today was the bool type. So in C, we don't really have a specific type for true and false. In a lot of other languages, there is a bool type, a Boolean type, which can either be true or false. But in C, we can't necessarily do that. So instead, what we do is we alias bool to integer. And we store either 1 or 0 in that integer, and 1 describes true and 0 describes false. So when we include okay, let's go over here. This might work by default. I don't know for sure or not. It might already be declared, but goodness, I'm all over the place right now. Yeah, so right now, false is undeclared. So same goes for true. If we were to try and use true, true would also be undeclared. So we get this error undeclared. So if we want to use true and false inside of our code, remember that we need to say include stdbool.h. And if we run this again, we can see that it does compile because we enabled the use of true and false in our language. So whenever, let's do this really quick here. So I'm just going to print out what A is. So true is 1. Oh goodness. And then compile that. False is 0. And then that's pretty much it. So remember, bool is just an alias for an integer, but what it allows us to do is show that we want a true or a false value stored inside that variable. So after we've included stdbool, what we can do is we can say bool, and then when we're typing Boolean variables, usually what we want to say is, and then the condition that will be true or false. So let's say is even equals true. So let's actually go back to what we were doing before, and I will go ahead and read into A. We'll just say up at the top. We'll try and keep our variable declarations up at the top of our program. So is even. And then we'll test to see if A is even. So A mod 2 equals 0. And then we'll set is even equal to true if it is, else is even equals false. So this doesn't really serve much of a purpose doing it this way. But for more complicated programs, it is good to store Boolean values, store the truthiness or falsiness of something. So let's say we were did some more operations or something, and we came down here and we said is even. We had a test that depended on whether or not our input was even. So now that we've stored that in is even, and we specify it here, remember that if we said, if this stores true, then this is just going to be true. If it stores false, it's going to be false. So if this is true, if we set it to true previously, then this statement will execute. So A is in fact even, still even, not even. So going back, talking about the logical operator OR. So remember that when we say OR, that means not. So this is read as not even. So we could change that. Say A is not even. That doesn't print anything. That does. So we can negate the variables, or we can negate Boolean variables, just the same that we can negate expressions that we are working on. So that was Boolean variables. So just remember, whenever we say true, it's actually saying 1. Whenever we're saying false, it's actually saying 0. Again, the only thing that bool does for us is it allows us to say that we want to have a true or a false value. We could do everything that we can do with bool and true and false with a integer and a 1 or a 0. So I could go back in here and I could change out all of these things. So instead of saying bool is even, so I'll take out, let's convert this program from using Boolean to just using an integer. So I could change that. So I changed that bool to an int. I went down here, and instead of saying true, I say 1. Instead of saying false, I say 0. And these will generate the exact same programs. The only difference is you can see what's true and see what's false. So when we're just using 1 and 0, we don't necessarily know, well, we know if we understand C, what's true and what's false. But if you're just casually skimming the program code and you see equals false or equals true, you pretty much know that that's a Boolean variable. That should only store a true or a false value. So that's that. So, any questions about the things I covered today? All right, if not, then we're going to start our in-class assignment. So what I want you to do is create a simple calculator. So you will read in a number, a character, the operator, and another number. So you should have, you should read it in like, well, I have my example. And then based on the value of the operator, take that action and print the result. So essentially you should say, remember we can do character comparisons like this. So let's say we had a char C equals A, and we wanted to test if C equals A, we could say if C equals A. And that would be how we would test to see if a character equals another character. So yeah, run dist day 9 for example. So dist day 9, very simple calculator. So if I said 10 plus 10, the result will be 20. So basically you want a scanf that has reading in one integer, one character in the middle here, and another integer. And then based on whatever this value is right here in the middle, you want to take that action and print out the result. So it can also handle 10 minus 5, it can also handle 10 times 10. You can handle all sorts of things. So begin working on that. If you have any questions, yell at me. Otherwise, that's all I have for you today.